team. This is a photograph originally of 410 10th Avenue. It was built in 1927. It's the Masters Printer Building. You all might know the west side was zoned for manufacturing, and that's why a lot of these beautiful buildings are on the west side, and you know now that many of them are being repurposed into some of the most dynamic and progressive buildings. And we think of this as one of them. It was at the time the largest concrete superstructure in the city, and over time, neglect, right? So, 90 years later, we got a dirty and unloved building, and a lot of unplanned things happened to it, and it no longer served the market. But the market came to it. This is today, or a week ago, and you can see that, I don't think it goes, yeah, it does go backwards. What happened in 3 to 4 years, the rest of the city grew around it, and this building had to find its place in it. And SL Green bought the building, and we were commissioned with a wonderful team to bring it to the current market. One thing I always think about, and with the help of JB&B, we got these numbers, and don't hold me to them because I wouldn't even know how they derived them, but everybody's heard of embodied or embedded energy. So why do we keep existing buildings? There's any number of reasons, right? There's that they're there, that they're occupied, they're bigger than they can be by zoning now. They have some inherent quality, like this building does, but some of it is based on the environment. And essentially what we found is by keeping the building, renovating it in a very intense way, we saved 65 million miles driven in not a Tesla, okay? So, in a combustion engine, 6-cylinder, probably at about 23 miles per gallon, but don't hold me to that. But the biggest problem in this building was the outside. That was what we found on the building, and it had been neglected. Those not fully the original windows. This is during a period when light and view is bad. I don't know where that came from, other than the 70s and the energy crisis. Because it was a factory, it had a 4-foot-high parapet. Behind that, the entire structure of this building, though it's clad in brick, is a concrete structure. So our study led us to lowering that to 30 inches, and I'll show you on the inside, tinting the brick with the Kind product to bring it into the context that it now inhabits, all those beautiful glassy reflective buildings, but also give the brick a little bit of boost in its performance in resisting in water. And that's a trend right now. If you're an old brick building, get ready for the paint roller. And not all buildings, of course. But what we found to be really challenging and part of the accomplishment is being able to change that window to a high performance window. 3 lights, those muttons are not broken lights on it, and we put in the cement panel, precast panel in there to give it a snappy look. And that's a 20% increase in the opening. These are our partners in the glass. It was all a product of a mostly Irish team, so Daniel, Patrick, Shannon had a fun time of that, and we had a very good performance with that. But the reason for doing it more than ever, why did SL Green come to us and say, get to work in transforming this building, is this. The workplace environment has transformed. We had a very high knee wall, as I said. This is actually one of the better floors that didn't have all the mechanical in the window and so on. And that's the workplace environment now with that. So what looked like a factory became a modern office. And as I said, that's the primary reason to do this. The neighborhood is very unique. 10th Avenue and then the entrance right next to those cars to the Lincoln Tunnel. So it's a freestanding building, very unique between 34th and 33rd Street. 33rd Street has become the promenade from the Penn Station transit hub to Hudson Yards. So, before the pandemic and resurrecting now is a slew of people coming down this street, and as you all know, it's a development corridor, so it's really the promenade. So what did we have here? We had a truck dock and a parking area there. We moved the lobby from 34th Street to 33rd Street, inhabited the old truck dock. Great thing about these buildings is they're over elevated for the time because they were factories, so we converted the big elevators into the low rise and the six pack into the high rise, and we had a Class A office building in terms of vertical transportation. But by relocating back to neighborhood and place, and then people relocated that entry into the old truck dock next to the garden that we worked with the Port Authority to do. Signe Nielsen did the work there, not very well shown in that picture. But again, this assembly were not quite jumbos, 8x16 lights of insulated glass with a steel mullion and pretty good values on that. And it does, this, as you know, East Side does get an extensive period of eastern sunlight. And for us, it's always mitigating between the visible light transmission and that solar heat gain. And that window product, I think, was very successful in that. Quickly, one other thing, there is one other enclosure that none of us have anything to do with that, and that's the outside, right? The outside enclosure. If we stop messing with it, it's one of the most valuable resources. This building, when we started on it nearly 4 years ago, not one of these exterior spaces were accessible. And with the team, we were able to make 20,000 square feet of the building exterior space accessible, including the garden. So that's an enclosure called nature that I think we all embrace. That was our view shed when we first got there, and that is it now. So it's a true transformation. And going back to the thesis, a building that we consider new, and it's now the home of Amazon and FRB, First Republic Bank, completely occupied. So very, very pleased, I think, with that, and very different. Now this one, we know that that's the original Penn Station, the greatest Beaux-Arts building in America, arguably. So if we want to get into that, we can. But 50 years later, by the way, read the book on this. It's amazing because they built the electric train in America, 2 sets of tunnels, amazing bridge, this thing, and then 50 years later, some knucklehead decided to take it down, and it's the greatest urban error of all time, and it was replaced. So that's a little low. I don't know why. So it was replaced with that 1.5 million square feet of bad design. And I think all of us know that brown is not the color of architecture. So we are, and we're a little bit low on the slide, so I don't know why, but if that can be corrected. But right now, underway, as you all know, and anybody goes to New Jersey or to Long Island, I apologize for the inconvenience, because right now we're doing a complete rebuild of the building that includes an enormous addition on the front, and a total reclad, and several other things that I'll take you through very quickly. This is about place. This is 7th Avenue as it was. In 2 years, that is 7th Avenue as it will be. The addition is what we're calling the bustle. It's 50 feet off the ground. It's 430 feet long. It's got a 70-foot free span, and each floor is 25 feet high. So it's a kind of a one-of-one situation, and that is the roof for a monumental public space that is where you gather for going into Madison Square Garden and into Penn Station. And we hope one day that we will celebrate both the Knicks and the Rangers in that space. Again, like this, the number got bigger. Why? Because the building's bigger. We're using a lot of energy to build it, but we're saving a lot of energy by not knocking it down. And every other day, there was a question, why aren't we knocking this down? One of the reasons is because we would stop all of the traffic of the trains on the Eastern Corridor. So that doesn't work very well. Could be done, but it wasn't necessarily the most feasible way. So I love the fact that 1.5 million square feet of building is going to go from the biggest dog to something that we hope is a contributor in the city. Why was it a dog? Because of that window wall. The precast on every is the column structure. So let's put the heaviest material on a building as a cladding. Does anybody think that's a good idea anymore? No. You've heard probably a lot about lightness, what's going on, you know, at the World Trade Center. The stone panels going on right now are amazing. I'm sure they're far lighter than the glass panels. The brown piece up the middle, you'll see in a minute, was the high pressure induction riser for air, you know, the air system for the induction system, and then of course dark reflective glass. So when you're inside the building at noon, sun shining in, you're wearing the very dark, you know, those wraparound sunglasses. That's what you are inside the building, a very inhospitable place for workers. And that's why we're all here, right? We're creating enclosures that make people effective, comfortable, happy, efficient workers, and helping the planet to the best we can. You can see on your right side is the new curtain wall, where we increase the vision area substantially by changing the mechanical system to a fan coil system, taking out the induction unit riser. I'm not a anti-advocate of induction unit systems. They're fairly efficient. Nobody likes the hissing noise. But on this one, because of where the risers were in the building, it really defeated the purpose, and we can really increase the quality of the overall energy model substantially and lower the spandrel. Those are the numbers. It's very interesting. Halfway through, there's a very long period of design and challenge. Halfway through, of course, the new energy code came out. We reset. We had already specified, bought the curtain wall with double glazing. And our client challenged us, is this the very best we can do? And the answer is no. And that was changing the entire building to triple glazing. For me, that's always a concern. We do a lot of work up north in Canada, and visible light transmission is incredibly important, not only in retail sections, but any commercial office and residential building. Always very concerned that we're creating too much reflectivity inside the space and so on. It's amazing. Any of the glass manufacturers in here today, I congratulate you for pushing the product to maintain that quality of transparency. We did want some coverage because there's still some ugly stuff inside the building. So it's nice when you see it to have a little bit of reflection on it, but enormously improvement on the values. And when the penalties start to hit, the building should be clear of those. There was an 8% increase in the energy model performance just on that decision. And we weren't clipped by the fabricator that much by that change. So I thank him, who is in the room today. But that's the number. So let's look at this beauty. That was the internal condition on the building on the left. This is in progress with the window wall, or the curtain wall on the right. Again, a very large increase, 43% increase, and we're pushing the building beyond the bounds of performance, even with that amount of thing, because no one's going to work in this building anymore, even if we lower the rents. And as you may have seen, they just signed a significant lease at over 400,000 square feet in the building, and more to come. But that's our vision of a workplace today, with the low boy fan coil units to complete that energy performance in the building. This is the bustle, as I talked about. You can see, I forgot to mention something that's, I know we're talking about exteriors, but this was not possible without the gift of the foundations of the McKinney White building. So these funny columns on cast connects are actually loading on the old cutoff foundations of the building. Couldn't have been done because we, as I said before, we couldn't stop train traffic. So I think there's only one foundation that we put in. Everything else is on spread grillage on the raised plaza. So that's a unique and a wonderful gift that the original building gave us. It's one last gasp. But this thing recreates up to the top of it recreates the mass of the building, and it means a little bit to us on the urban point of view. But again, 50 feet off the ground, 430 feet long, and it's got a third facade, and that is that full thing of a fully functional dynamic display, 250,000 LEDs. It's being fabricated by Mitsubishi. We just reviewed a very large mock-up of it, and it actually works. So it can be rented for birthday parties and bar mitzvahs. And you can see here the numbers on this. This in particular, they are jumbos. They're 9 by 22 feet high. And it's really thrilled with the quality of that. Those are only double glazed. And they do have great transparency, very good performance numbers. That's inside. I'm going to start moving. A couple other things to talk about. We moved the entry from the middle, which is where between the two vomitories, into Madison Square Garden, because that was a congestion area, to the north side, and that is going to be a glass fin system by Sealy, and those are also mammoth pieces of glass. I look forward to seeing the truck trying to articulate its way into 7th Avenue. Again, we'll warn you that day, so don't try to take a train out of town. And so this is a picture that shows the different wall types we have here, the jumbos in the bustle, the curtain wall, the acoustic panels, glass panels for a 200 and some odd person auditorium, because you can't build an office building of this size without an auditorium, evidently, anymore, but I'm all for it. It just means more challenges and more fun. There's a lot of new storefront, and of course, as I mentioned, the glass fin system. And you see the new entry to Long Island Railroad by SOM there that was finished with a unique cable net system. So there's a sixth one there. So you kind of use all your techniques on this. The anchoring system is that's a standard curtain wall on the bustle, but the anchoring system really relies on the original mullions to the building. So it even gave a little bit of itself to make the new happen. And again, we're going to talk about another important enclosure, and that's the sky, 75,000 square feet. This wonderful terrace on top of the bustle, and we're cutting balconies into the western corners of the main building throughout these double height spaces, and then an extensive roof park on top for people to enjoy that which is our climate. And finally, I just want to compare these two. One whose inherent character really was the gift, and one whose history was the gift, but what was there was nothing but bad. And with that cue, I'm out of here, and I just want to thank everybody on that NASCAR thing, because it is a team effort and a terrific one. Thank you all.
Thank you, Dan. So to keep it going, we'll forego the Q&A on this particular one. AJ Labelle is next, and we're going to move into sort of documentation and procurement, which I think we've learned this morning is a critical element as well as we progress. So, AJ?
AJ Labelle, everybody.
Your state.
Good job, man. All right. Let's have some fun. Okay, so that's forward and backwards, yeah, okay. Excellent. We're gonna have some fun, I think. I have good news, bad news, and good news. The good news, I'm not gonna talk about energy, right? I saw a lot of helicopters out there, right? And it's not that it's not important, but they gave me 20 minutes and I talk a lot, right? So unfortunately, I figured, forget it. The bad news is I'm gonna talk about documentation, which will put you right back to sleep, right? But it's not just documentation. What I did is I got a couple of slides that are going to be bullet points, and then I'm going to show you a whole bunch of pictures, and we're going to ad-lib. And I'm going to show you some stuff, which is the good news again. I'm going to hopefully blow your mind, because there's a lot of cool stuff that I'm going to show you. At least I think it's cool. Hopefully you'll think the same thing. So that's me, right? That's a typo. That's actually 31, but I'm trying to fool everybody into thinking that I'm younger. All right, I've been in the industry for a long time. There's a lot of people here that know me. For those of you who don't, I started way back when as an inspector, and I went through the ranks, and I became a partner in an old firm, and I've worked in all the continents that I know have buildings of Class A nature. I work with a lot of famous, not so famous, and everything in between, all the way from developers to manufacturers. I've been involved in some really interesting and not so interesting projects. Again, it's not beneath me if you guys want to, it's very high level discussion. If you guys want to get into details on some of the stuff you're going to see today, it's not beneath me to have you come to my office and invite me out for lunch. You pay. Okay? Design assist. Who the hell knows what that is? I don't know what it is, because everybody tells me it's something different, right? When I talk to a developer, he tells me one thing. When I talk to a manufacturer, he tells me something different. When I talk to an architect, a designer, a banker, a lawyer, they all think it's different. This is the only official description. And of course, there's a whole bunch of, as you can see, the ... There's a lot of legal mumble jumble that goes on below that. But the really important part is one sentence long, right? I put delegated design up here as well, because that is now a buzzword. I don't know if you guys have heard it a lot. Everybody's throwing that around. Delegated design. It's basically a design assist, but you pin it on someone. So, welcome to read it. It's the AIA document. I'm not going to. Okay, design assist and the usual components. Way to document prototypes during early buy or delegated design. Documentation, old school, 2D. Right? And I'm going to get really into specifics later on the pictures, but these things are really how it breaks down. 2D is the way we all used to do it. It used to be vellum when I started, and now it's actually, believe it or not, on the IAC building that we did on the West Side Highway, the the shop drawing review was actually virtual. How's that work? Well, the manufacturer, we did a model, 3D model. We fully finished the 3D model. The manufacturer took that model and threw it through a Unix system that turned it into numerics that went straight into the manufacturing machine and made the pieces. And the only way that we actually verified that the system worked is we took the pieces in the factory, kind of like went, oh yeah, it works. We never saw documents for that job. The only documents we saw was just basically because the lawyers told us we have to review documents. So they used to take pictures of the model and we just looked at, but at the end of the day, you know, that's the usual progression of documentation. AI is next. You know, the metaverse, we're going to be able to review stuff in the metaverse. I don't even think we're going to build actual buildings anymore. We're just going to basically look at them on the metaverse. Material science, a lot of the early design assist stuff that I've done in my career has something to do with noble metals, glass, concrete, and masonry. For whatever reason, those are the four. Mock-ups. Again, I'm going to blow your mind with some of the stuff that we've done. And, you know, it's self-explanatory. I don't need to read it to you. Innovation, means and methods, administrative. All of this stuff, really, if it works out, is for the last line. Scheduling, how much does it cost, and how much risk am I taking by doing all this so early? And I'm talking about so early. I'm going to show you the genesis, a sketch of a genesis of a building that's actually built, and you won't believe where it started and how it was done and where it ended up. Okay, personal experience. Start working from the concept stage. I've seen design, I've worked with designers, they've given me the back of a McDonald's tray mat. This is my new design. I want you to work it out. How the hell he got a McDonald's mat? I don't know, because he doesn't look like the guy who eats McDonald's, but so you start working, and I'm just a facade guy. I don't do anything else other than facades. So for him to actually come up with an idea sketched on a napkin, and me start work on the facade that way it's awesome, right? Do not get distracted with any prescribed phases. The developer, it's like he wants early design, early buy, design assist, blah blah blah, but he's like when, and then all of a sudden when you start pouring your heart and soul into it, oh, you need to follow the you know, architect of records submission for payment. You know, SD, DD, CA, they don't go at the same pace. Set expectations with ownership. You want to do a really risky building, you better start up early, and you're going to have to put some money into it up front. And you'll see by some of my examples, if you do it right, you get a tenfold back at the end. Hard to convince a developer to do that, but it's actually proven, right? Think outside the usual boxes. I don't even need to say anything because I'm going to show you. Prototype samples are crucial to validation. We all know this. Right? We can sketch, 3D, document, engineer, calculate, the living out of everything. But unless you build prototypes, the proof is in the pudding. 4 case studies. I took them across my career as the best examples, well, because none of them say over budget. Because there are a couple that are over budget, but that, you know, for whatever reason. First one is in Rio de Janeiro. That was under budget, ahead of schedule. I don't know if you guys can read the bottom, but I'll read it for you. I did this one in Sydney. It was on budget, on schedule. This one in New York, I'm sure you've seen it. It's that big thing over in Central Park, right? That's on budget, on schedule, quote unquote COVID. What is schedule with COVID? We all lost a year and a half of our lives. Last one is Arles, which is in Provence, in south of France. On budget, no budget, sorry, I put a little smiley face there. Yes, you do get, in your career, once in a while, you get to come across something that doesn't have a budget. And that's on schedule, or it's finished actually, they opened it 2 months ago. Case study number 1. Pato de Maritima, I did several years ago. This was challenging. The reason this was early design assist was because the mandate from the developer was, I'm building a Class A building in a place that's not used to Class A engineering with a very famous modern architect who designs complicated stuff. So the mandate here was get started early, get the local guys to actually get involved, transfer your knowledge to them, get it, get them on board and get it done locally. And I went, uh-oh. So anyway, this is actually in the area of Rio de Janeiro. That's a new portion of waterfront property, and it's going to be their Hudson Yards, basically, and this is one of the first. So we did these, that we did in a restaurant, and you can see the 3 different phases. I'm showing it here, and I'll explain the last one. The last one's a little complicated for those of you who really like to dig deep into details. What you're seeing there, you might get it, and believe it or not, it's actually what we did. We started with the designer wanting it is a serrated facade. They wanted a hockey stick shaped unitized panel, which we all know, or for those of you who dig deep into curtain walls, a hockey stick shaped panel unitized, it's some heavy lifting. It's in engineering, it's complex, so we said, okay, let's dumb it down. We are in a place that doesn't have this type of engineering. Let's actually make it in 2 components. Let's make the glass and metal be a glass and metal rectangle, and let's work on actually coming up with an idea to make the articulation with a cage, and we clad it, and that, of course, that morphed into something that doesn't have the structure because it got in the way of the structural beams, and then all of a sudden we had news from the developer and the GC that they were going to change the building from all concrete to steel with a concrete slab. And we went, aha. So how can we actually make this? And again, this is very early on. The hole wasn't even dug. We were knee deep in it. What did we do? We actually brought, this was really crazy, and I still think that it would never happen in the United States, too many lawyers, but what we actually together devised was to actually pour the slab all in one flat monolithic pour with an actual joint, and the structure, the steel structure itself had a hinge. And what we did is, once it was poured and cured, we hinged it, we took the temporary supports out, we hinged it down to meet the geometry requirements of the facade. We clad that portion with, and again, I'm not going to get into energy and sound and all that. We clad that portion, and then we infilled, and there's the prototype. Then we infilled with glass. It's a regular rectangle piece of glass with all the right energy requirements and all the right safety requirements and the visual and aesthetic requirements. We talked about prototypes earlier. This is an actual steel structure as we did it on the building. This is a prototype that we did at their steel manufacturer's plant. We poured the slab. This is the temporary support. We removed the support. That portion of the slab was hinged down to make the geometry. And then once we figured all that out, and again, this is before even the contract was awarded, we said, okay, now we know what we're doing. And did I hit backwards? Sorry. Now we got into the modern world. We 3D'd it. We 3D'd everything. Because again, the mandate there was, we're giving it to a manufacturer in the local market that is really not engineering savvy. So we need to spoon feed them as much of the information as possible. So from all that initial work, we were able to actually 3D model every single bit of this facade. And this is the lower, this is what they called, Foster's people call this the underbelly. I don't know why, but it's more like a skirt, glass skirt. As you can see, we did a very technical facade in a place that was just really not prepared for that sort of technical. And this is a very complicated truss that has nothing in, it bends halfway through its distance, and we hung it off of internal hanger supports off the actual vertical structures, and we glazed it, and that was that job. This is second example of very early. This was really early. The designer came up to me, I'm sure you guys all know who that is, but he came up to me and he says, I want to build, we've been awarded the building at the University of Technology in Sydney. We want to build something, but I don't want it all to be glass. I want it to be glass, and I want it to be And this has to do with energy, but I want it to be not all a glass box. So this building has been finished for about 6 years now. Very initial concept, doesn't even look like the building that we built. This here is to show you how uncooked the ideas are. He wanted a glass module, he wanted some solids, and this is, example on all the jobs that have really intricate, complex geometry. This is actually a ruling line study. I don't know if you know what a ruling line is, but when you take a concave or a surface that's actually curved, you can either have a compound curve or you can have one that has a ruling line. A ruling line is a line that actually travels through, at some point of that section, it travels straight. This is a very initial study. The end result wasn't exactly that, but very, very beginning, very end. Sorry again. The progression, again, all this stuff, the facade wasn't awarded, and some of the facade wasn't even finished. The design wasn't finished. So we started, and I'm sorry about the pictures, but sometimes you take them in factories, and this is probably a camera before cell phones. So we discussed about backup walls. You're going to hear me a lot saying backup walls on the other jobs too, because the skin of the facade is always the weathering component, but there has to be a backup, not just for energy, for use group, for buildability, constructability, unitizing. So we started with a truss concept, as you can see. We did, that's a constructability mock-up, that's the performance mock-up that we did. To make a long story short, we were looking at precast, we were looking at all sorts of materials. At the end of the day, by analyzing the geometry, analyzing the cost, and doing all these prototypes, we realized that using regular standard masonry with standard masonry components was the only way to build this building. So that was good news, because now we went back, okay, standard components, we can do shop drawing review. So we reviewed the shop drawings. As you can see, we did use modern technology for the backup. That does have ruling lines, and I'll show you in the next slide, but this was glorious, because now we could actually review something that we knew and loved and been doing for many years. That's the mock-up. Those are actually, you don't see all the components, but the shelf angles, the ties, the unit struts, the backup, the waterproofing, it's all standard materials. As you can see there by that picture, that actually shows you there's a ruling line there. So we don't get too complicated. And of course, we devised the current standard materials to make those curves and make that happen. And that's the finished product. Everybody worked so hard on this project. I wanted to put that picture over there because that guy cared so much about what he was doing. He says, I'm never going to build another building like that. I'm actually going to tattoo the brick pattern on my arm. So we had to take a picture of that. He went home with that after he was done with the building. The bottom line on this one is we did a whole bunch of prototypes, analysis, and material science, and we did the 3D models. We did all that work. And I got to tell you, this sounds all very sexy, but at the end of the day, that particular guy who did this particular wall, at the end of the day, we would print an 8.5 by 11 from the model the day before he went to work, and we would give it to him, which is a section that we knew he could do 365 brick a day. That's how much he laid, right? So we'd give him that, and after all that technology, he looked at it, put it down, and he would grab a brick, butter it up, look at the wall, and go. So this one you guys know, it's over there. The reason I wanted to show you this one is because we did a very early design assist with this, so much so we were so early that I think we were the second person to know who actually got the job to design it. And we said, okay, we're in New York, this is Smith Gill, right? We said, we know those guys, let's go fully electronic, let's just basically put the pedal to the metal, and these are two of the models that we did. We used a program that basically designed the entire wall down to the screws. We knew that there was 5,257,210 screws. So whenever, and why did we do that? One, the client asked us to, and two is if you moved one thing, you know, it's not, oh, let's add a screw there. Whoa, it's not one screw, it's 257,000 of screws, right? The job is so large in scale, it's 1,500 feet. I mean, you guys know it. It's the tallest residential building in the Western Hemisphere for now, not for long. That's some of the progression, which is the documentation. We started with just basically the geometric dimensions and the profiles. That comes out of the model, which is, again, not before it was awarded, and then it turned into a shop drawing. And pretty much Lisa did that. They did a good job designing it. And you can see the progression that came from early documentation, but this thing wasn't even sketched. We went straight to 3D, and we did it early. That's the old one that actually had the spire on it. The job is huge. There's no other way to do it. And the funny part about this is this job actually needed its own computer to do the 3D model. We couldn't just take the file, a disk, to Chicago. We actually had to unplug the computer and bring it with us because the file was so large. What allowed us to do by doing such a finite model is, you know, we could actually double check the weights of the aluminum. We knew exactly, and again, that's when the developer all of a sudden wakes up and says, oh, wait a minute, I can actually see how much it's costing to do all of this stuff, whether it's to save or not. And sometimes it's surprising because on facades, the developer thinks he's saving money by doing something, but by saving the design and proving it to him through, or her, through this stuff, you can prove them wrong. And this is some of the mock-ups. This was, you know, again, part of the, before the job was awarded, there's some competition that's thrown out there, and I've done that on other jobs where you get two companies to give you the same product, and you try to see, in this case, it's about glass quality. That one over there was about constructability. This is a great picture. This has nothing to do with the Ford projects, but I put it in this one because this is Louis Vuitton in Paris. We 3D'd this thing to the millimeter, and a German manufacturer made it. That bust is actually in the 3D model. Some young guy or girl in the office was making the model, and they said, oh, I got a clash. Screw it, I'll just leave it. They built it. It actually went all the way through the process, and of course everybody else is looking at the facade, looking at all that. I was taking pictures of this, and they're like, what are you doing? And I'm like, this is an example of how good the model is, and how pesty the manufacturer was to say, it's a clash, you don't want to listen to me, I'm going to build it. Last but not least, we just finished the 2 months ago. This is a cultural center. Luma is actually, the developer, Luma Foundation, bought the land and all. It used to be still a rail yard that was used by the Nazis to put prisoners into trains and send them to concentration camps. The founder of Luma Foundation is the daughter of someone, I can't name, but anyway, she grew up in all, and she felt in her heart that she wanted to redevelop the site, that it was nothing but a gloomy, you know, it was still a rail yard, believe it or not. And she said she likes photography, so she said, and she used to have their version of the Sundance Festival for photography and all. She said, I want a cultural center, and it's actually spawned into a hotel and some other stuff, but this was the anchor project for that whole redevelopment, and it's still going on. So again, I'm sure you know who that is, called Frank, and Frank started working on it, and here's the genesis of some of the stuff, right? This is an example of how viscerally simple an idea can actually be before you get to the end. This is stuff you sketched, this one's, I think, sketched on an airplane. But you talk about it, and you sketch, and you put on some dimensions, and you say, okay, and it's not actually what ended up being, but it started the thought process, and the mandate to us was, and this is how early in the design process, this way it goes, I want it to be unitized masonry, but I don't want it to be masonry. What? I want it to be masonry, I want to be like masonry, but I want to have the qualities, the crystalline, reflective qualities of glass. I don't want to use glass. I want to use something that doesn't exist. So off we go. We were doing all sorts of crazy experiments, and some of these he's considered for other jobs, and it goes on and on. But anyway, so we start with this. This is the facade. This is what he wants it to look like this, but he wants 2 or 3 rules. And I said, well, this is too artisanal. You can't really build a facade like this. I mean, you could, but you know, that's a pyramid, right? You can't, not cost effective, not real, not performance-wise. You can't do it. So I said, let's make his request real. Let's take the artisanal approach and let's blend artisanal with what we know can be mass-produced, and then take that and make the mass-produce back to artisanal. So what we did here is we actually laminated 3 pieces of glass. The outside one is it's not cast. We tried casting, but the outside one is a slump form onto a mold, and then we laminate it for safety and other reasons. We laminated and we made these C shapes to reduce the weight and to create that kind of look. All right, and I said, okay, we're close. But he says, but it's still glass. Okay, well, all right, so he says, I want metal. If I can't have stone, we couldn't have stone because of the geometry and the weight. So those 2 pictures basically just show you what we were doing there. So he says, I want metal, and I want this sort of metal he's kind of thrown around a few times on some of his projects. This is actually, this is expanded aluminum. It was used inside of Humvee doors as safety, blast mitigation, shrapnel mitigation. And he said, okay, I want to try to use it, but it's obvious. I mean, I told him, I'm like, yeah, well, first you're going to kill every single sparrow in the neighborhood. And secondly, how do you clean it? You don't clean it, and it's going to be one big colander. Okay. So I still want metal. And the slides are matching the wrong position. I'll talk about backups. This is the next slide. So we said, okay, he wants metal. Let's work on metal. But again, like the other job, we need a ruling line. Didn't work on this job because it was so geometrically challenged. So we actually came up with what they call direct offset on a component, right? And then from that we said, okay, well, we have to hang whatever we're going to hang onto something. Because the facade is so geometrically challenging, what is the best material we can use? Let's try to use a tube. That's easily bent, right? And then we figured out, okay, it's easily bent, but how do you attach to a tube? Then you have to do all sorts of things to the tube to attach something to it. So then we said, okay, why don't we come up with a truss that has a pattern cut plate that actually has a direct offset to a backup wall, and then we'll clad it with whatever that is. In that case, it just happens to be panels. And then he said, okay, metal. We started looking at metal. Stainless steel is obviously the choice. Titanium was not a choice. And nothing else was a choice. Stainless steel was the choice. And he wanted a certain look. He wanted that glass, whatever that je ne sais quoi is. It's very reflective, very crystalline on metal. So we're like, oh boy. And I wish I could show you the videos. We tried everything. We tried rose budding. For those of you who don't know what rose budding is, we tried to actually weld the back of the panel. We tried embossing. We tried throwing darts at it. We tried throwing bricks at it. We stretched it. We shrunk it. We froze it. We melted it. We did everything. And it was never what he wanted. We did come up with it at the end. Anyway, the coil stock, simple enough, right? We make a box, and then we said, okay, well, since we're doing this sort of box, that's the theme, instead of having all those pattern plates, why don't we actually do a clip to the box needs reinforcement, so let's do a clip system to the box, and to get rid of all that other touchkits that we have going on the wall, which is the truss and and we kept going. Again, the job hasn't been awarded to anybody. This is still between the owner, the architect, and the consultant. And then we're getting closer. Now, I think this was a cricket bat. I don't know. But we're getting closer, right? At the end of the day, we're getting closer. We're almost done here. Voila. The turnkey moment on this job was when we went from, these guys aren't facade guys. These guys built oil platforms. Someone recommended them to us, and we said, okay, let's go. We're in. I mean, that's when I say think outside the box. This is an oil platform rig builder that built us a geometrically correct stainless steel panel, stitch welded, and then through penetration welds with the shelf angle. That's the sample. And then we finished with, that was the final look on the box. We fine-tuned that clip system. And then once we knew what we were doing, we're back to doing a 3D model. We modeled every single block on this job just to make sure before it was awarded. When it was awarded, we knew exactly what we were doing. And, you know, take it all in. I'm not even going to say anything. Just take it in for a minute. I'm still wigged out over there. I was like, oh my God, my career's over. Huh? I was busy working. Anyway, yeah, this is awesome. And again, anyone that wants to come over, it's going to cost you lunch. I'll be more than happy to spend more time with you. It's really 20 minutes is not enough. That's the finished look. I mean, by default or by design, the sun shines on it, and that's it. Thank you. You're welcome.
Sorry, I have to keep things moving, but we have to be respectful for everyone that is here. So the next conversation is going to be Brendan Mercier, focus on rain screen, sustainability, insulation, a lot of different things. So let's just jump right to it.
Okay, let me see where the, oh, thank you. I'm going to watch you do this. Clock is still, yeah.
They'll reset it.
Thank you for being here.
Brendan, right?
Yes. Thank you.
Testing, okay. Hello everybody, my name is Brendan Mercier. I am the National Facade Manager for Cosentino. Cosentino is a surfacing manufacturer. A lot of people know us for our interior products like silestone and natural stone, but we also have a newer product that's been around since 2013 called Dectin. Dectin is an ultra-compact surface, sort of the next evolution in engineered stone surfacing. And I want to talk today about the importance in the symbiotic relationship between sustainable building design, sustainable products, and sustainable manufacturing. You know, when we talk about sustainable buildings, when we talk about having buildings that are going to stand the test of time, that are going to reduce the carbon footprint, it's important for us to realize that just because a building is efficient doesn't necessarily mean that we are lowering the carbon footprint worldwide, because it depends on the type of products that we're using. Are we using products that are sustainable? And how are those products manufactured? So we're going to get into a little bit of each of these topics today. So the first thing I'm going to talk about is sustainable building design. We're really focused on rain screen design. So obviously, for a long time in the United States, the single skin construction was sort of the main way to build a building. And we know that there are a lot of drawbacks when it comes to this, because what we're trying to do is keep water, keep moisture out of a building. But moisture seems to always find a way. It's kind of like Jurassic Park when they say, life always finds a way. It's like that. Water always finds a way to breach a building if we're trying to keep it out. So what happens if water breaches a building? Well, obviously we can lead to issues with maintenance. Maintenance obviously is not good when we're talking about reducing our carbon footprint. We can have issues with the product, maybe freeze thaw, or if it gets really bad, maybe it comes down to mold, mildew, or structural damage to the actual building as well. So there are a lot of potential issues, as we all know, that moisture and water can have. So that's the first thing when it comes to rain screen design, is that we're building a better building to manage moisture long term, but there's more to it. It's not just moisture, because when we think rain screen, we think of rain, obviously, but it's more about building a sustainable building, reducing the energy needed to run that building every year over the life of that building. And that average savings, obviously there are a lot of factors, windows, how it's built, what your R value is, but overall you're saving on average 30 to 40% using a rain screen rather than a single skin construction on a building. Now rain screens in Europe is the standard way to build the exterior of a building, and they've had a rain screen association for 30 years. In North America, we have a rain screen association for 2 years. So this is sort of still something that's being developed, something that we are still growing in our market, and we're really at the early stages of that. But we are going to be growing, I think, exponentially, because we are really looking at the environment. We're really looking at the long-term solutions of building design. So here what we're doing is really trying to maximize that sustainability, low maintenance, long-term builds. There are multiple types of rain screens, pressure equalized, drained and back ventilated. Both work slightly differently from a scientific standpoint, but both do the same thing, manage moisture and make a more efficient building. So some of the benefits that you're going to get, some of the advantages when we're talking about a rain screen facade, and I've kind of mentioned many of them, is overall what we're trying to do is save energy, reduce the carbon footprint of that building, and hopefully also reduce the carbon footprint of the products being used on that building. So a traditional rain screen system, for those of you who don't know, probably many of you are pretty familiar with this type of construction, really just compromise of a system and then some sort of panel that is hung onto that system. I'll go through a few different ways that you can hang that panel onto the system. I think for many large panels, large format panels, we're going to use some sort of hidden anchoring or hidden fixing system. So in this case, we're going to have your L-clips, which are going to be attached to the structural wall. You're still going to have your exterior sheathing, you're still going to have your waterproofing, but then you're going to have your L-clips. Those L-clips, hopefully, for using good systems, are going to be thermally broken to reduce thermal bridging, to reduce the transfer of that heat and cold from the outside to the inside of the building. Obviously, that's very important. Then we're going to have continuous insulation. Continuous insulation is going to increase the hour value of your building. It's also going to move the dew point out from your weather barrier further out from your building. So that condensation point is now further out from your building. So again, also reducing that transfer to the building. You're then going to have some sort of vertical rail. That vertical rail generally is just going to be made of an aluminum system. You could be made from stainless steel or other things, but aluminum doesn't degrade. It's light, and so that's really great for this type of system. If you're going to be attaching with a hidden anchoring system, you're going to have a vertical rail, and then you're going to have your horizontal rail. That vertical rail is important to make sure that your building is flat, that your wall is flat. So if you're recladding an existing building here in New York, for example, and you have existing brick, well, maybe you don't have to remove all of that brick, you can go right over it. And so these vertical rails are going to be able to account for any out of squareness that that building might have. Once the vertical rails are flat and plumb, then you can put your horizontal rails on. Panels can be cut locally on site at local fabricators, or can be shipped by size to the job site. And then they're just going to be hung onto that system with some sort of clip and rail. So here's a picture close up. We don't have the insulation in this picture, just so you can kind of see the full system. So the thermally broken L-clip, your vertical rails, and the width of that vertical rail can vary depending on how much insulation, the thickness of your insulation, or how thick of a cavity you need. And so that can be that can range anywhere from a couple of inches to maybe even a foot or larger, depending on what you need from your building. So here you see that. Then you have your horizontal rails and your clips. So your panels, once they're hung, have a last-minute adjustability to make sure that you're going to have a completely flush and plain building. So this is great for new builds, but also great for renovation. So this is a way that we can increase the energy efficiency of buildings that are already built, right? We can add that exterior insulation. We can add an additional panel. We're going to reduce the solar heat gain because our building now, the skin is being hung off that building. So there's a lot of benefits for reclads, and of course we want to make all of those old, not so efficient buildings up to current building standards. Other ways that you can hang panels, maybe not so common yet here in North America, but very, very common in Europe, is with adhesives. Adhesives sometimes get a bad rap in just people's minds, and they say, well, it can't be as strong as a mechanical attachment. These adhesives are very similar to adhesives used in air shuttles and building rockets, so they're very strong, they're very lightweight, and so this is a pretty great way to hang a panel. And in this case, because you don't need anything mechanical, you can get very thin panels, 4 millimeters, 6 millimeters, 8 millimeters. So we're also reducing, how many natural materials and minerals are used in the panel manufacturing. So I talked about two types of rain screens. The first two that I showed are drained and back ventilated rain screens. There also is a chemically attached pressure equalized rain screen, where this is going to be more of a closed joint system, and it's going to create equal pressure on the outside and the inside of the cavities. Where the drain and back ventilated rain screen is going to create a near constant airflow to remove any moisture that gets into that cavity as it tries to create equal pressure, whereas with this system you already are creating equal pressure on both sides of those panels, and both sides of the cavity. What's unique about a pressure equalized system is you're always going to have beautiful bonded mitered corners, so you're never going to have an unfinished look. So whenever you have an edge, a return, and this also gives you an opportunity to create geometric shapes. So if you wanted to create 3D shapes or 3D models on the outside of your building using large stone panels or other types of materials, you can create some unique designs. And because you have those bonded mitered returns, you can also create different depths in your design without having to change any plane of the system. So it's also a really unique way of kind of design. So different systems for different design intents, but they all do the same thing. We're making a more efficient building that manages moisture better, that's low maintenance and longer lasting. And that's really what it comes down to, reducing that carbon footprint. So when we talk about sustainable products, obviously I'm sure you've heard about a lot of things about reducing embodied carbon. But when I talk about sustainable products, there's a few things that really stand out to me. Obviously, the responsibility of how you use your materials, your responsible materials, be it raw minerals, be it recycled materials, whatever you're putting into your product, it needs to be done in a responsible manner. So that environmental impact is really from the extraction of raw minerals or raw materials all the way through the end life cycle of that product. So it's really important, to look at products that have HPDs, EPDs, that are carbon neutral. There's a lot of things that go in to the different products, and of course there are many different certifications depending if it's wood, depending if it's stone, but those certifications mean a lot. And for me personally, I think that symbiotic relationship of sustainable products also comes from a manufacturer standpoint. So we need manufacturers that are also continuing to innovate, continuing to put money into sustainable manufacturing practices. And then also there's something that we don't always think about when talking about sustainable products, and that's the socioeconomic aspect to it. Are we treating people fairly? Are we having fair trade? Are workers being treated in a healthy and sustainable way? And what are we doing from a social and ethical practices? So we think about the product and how it's made from a green standpoint, but we also need to think about who's making that product. Are their lives healthy? Are they being treated fairly? And are the materials that are being gathered being done in a fair way? So fair trade, sustainable work ethics, and the people that are involved in manufacturing products are, I think, something that's overlooked sometimes when we're talking about manufacturing. And I think that these conversations need to happen with manufacturers, and I think that we need to be more open as manufacturers and more open and honest about our work practices. And I know that there are some great manufacturers in the market that are leading the way in this case, but sustainable products are more than just the sum of their materials. That's what it boils down to. So sustainable manufacturing. So we mentioned that in a fully sustainable product and a full sustainable life cycle, how you manufacture is extremely important. And this is something that is obviously going to innovate. And as we create new technologies, these factories, these manufacturers need to also innovate. So today, there are many practices that factories can go through to reduce their carbon footprint, to reduce the energy that it takes to produce these products. Water management. Obviously, water is a natural resource, and the water that we reduce in consumption is very, very important. So recycling and reusing any water that goes into your manufacturing process, essentially anything that doesn't evaporate in factories and in plants can be recycled through closed-loop water filtration systems and reused in future manufacturing. So water management is very important. Raw waste and raw minerals. My company manufactures products that use raw minerals. So what happens to those minerals if those minerals don't fit into a product? Generally, when you manufacture stone or when you manufacture many products, the beginning and the end of that manufacturing cycle isn't usable. That can't go to market. So is that just waste? Well, in many cases, for many years, that was just waste. Or what can we do to upcycle it or recycle it? Well, now, those slabs that don't meet the criteria to go to market can actually be broken down outside of our factory, reduced back into mineral dust, and the mineral dust can be reused for future manufacturing, or we can break it down into particles that can be used for bike paths, that can be used for roads, that can be used for rocks for irrigation systems. So there's a lot of ways that you can now upcycle and recycle products that just use natural minerals. So if there's resin that goes into a product, it's much more difficult to break that down and reuse those minerals. So maybe you can upcycle it, but there's no way to sort of recycle it and use it in future manufacturing. Energy savings, obviously, are very important. Automated transportation, automated manufacturing, very, very important. And then we're always going to have a carbon footprint. So how do we, as manufacturers, reduce that carbon footprint? By helping around the world globally in reducing carbon emissions. So what can we do with our pockets, money that we spend to reduce carbon globally? So that's how we can offset those carbon emissions that we still have, because there are going to be some, and every year we're going to try to reduce those carbon emissions, but it's never going to be zero. So how can we then reduce that carbon through public works projects around the world to sort of give back to Mother Nature, to give back to the environment? And these are questions that we really want to have with architects, with designers, with consultants, with building envelope consultants, engineers, et cetera. And we want those questions to also be asked of us. I think that it's important for manufacturers to be transparent in what they're doing and how they are trying to also reduce their footprint. So I think that's important. So quickly, I just want to take 5 minutes just to talk to you about Dekton. Dekton's a unique product. It's most similar to a porcelain panel, but I guess what you could say is it's the next evolution of manufacturing of engineered stone. What we're doing is taking natural minerals, and we are recreating the metamorphic process in a controlled environment, reducing the porosity of the material and reducing those micro defects. So there are a lot of benefits to that long term from a sustainability standpoint, because there's low maintenance, low porosity, no staining, very easy to clean, and that's sort of the basic outline of it. So what we're doing is taking natural minerals. All of the coloring, all of the composition of the slabs are also made from natural minerals. So any of the coloring, so if it looks like wood, if it looks like marble, if it looks like metal, all of that is also made with natural minerals. And the nice thing about that, like I said, is there's no resin. So those slabs can be broken down after its life cycle, recycled and reused for future manufacturing. So that's kind of unique. What's important to note about natural and organic minerals is they don't fade, degrade, or change over time. So on the outside of a building, that product is going to look the same 5 years, 10 years, 20 years, 25 years. And so your design intent is going to stay the same for the life of that product. So here you can see just a little of the factory. That press in the middle is unique. So it's a 25,000 cubic ton press, which for those of you who don't know metric, like myself, is about 50 million pounds of pressure. Or if you don't know pounds, it's about the weight of 111 Statue of Liberties, or 50 blue whales, or 2.5 Eiffel Towers. So I don't know how you like to measure things, but that gives you a good idea. It's very heavy. So it's the unique press. There's none like it in the world, but that press makes it very compact. So that's where it gets low maintenance. So it's not going to stain, which means you don't have to seal it, which means you don't have to worry about harsh chemicals or cleaning products to make it look good. And also, it makes it more scratch resistant and also stronger. So less breaking, less chipping, those types of things. And then we go through a sinterization process. So porcelain sintered, right? But it's sintered a little bit different way. We ramp from room temperature up to about 2,300 degrees, where those minerals turn to a gel. And as they turn to that gel, they bond on a chemical level. So just minerals, and that's why it is a pretty incredible product that can be broken down after the fact. That temperature ramps back down, and as it cools, we've created rock. So it takes hundreds of thousands or millions of years to make igneous rock, natural stone, granite, marble, travertine, etc. So instead of 100,000 or millions of years, we do it in about 5 hours. So some of the things that we have taken from a manufacturer standpoint, when we talk about sustainable manufacturing, we're trying to implement as many of those into our factories as possible. So we are run off 100% renewable energy, both solar and wind, and every year we are reducing how much carbon footprint we create at that factory. And yes, that does take an investment from our company, but that investment's important because it's giving back to the environment. And that's something that we can't ever change once we hit to a certain point. So Decton, I mentioned, is a carbon neutral product certified by United Nations for the entire life cycle, so cradle to grave. And obviously, like I talked about, environmental product declarations, you can really see from the extraction of raw minerals through the life cycle of that product. And I really think that every product should have an environmental product declaration so you can see how sustainable or what's going from beginning to end of that life cycle. Are there recycled materials going into it? Can it be recycled after the end of its use? And these are things that we need to talk about, not just in sustainable buildings, but sustainable products, and again, sustainable manufacturing. It really is a symbiotic relationship between all of this. And for so long, I think we just thought about efficient buildings. We didn't necessarily, we heard green products, but green products are great if they use recycled materials, but if that factory is pushing out tons of carbon emissions and not offsetting those, using a lot of energy, those are things that we didn't necessarily think about for a long time. So I'm not going to go through all of these, just because I just have a couple of minutes. But UV stable, non-combustible, very important for exterior envelopes, and sustainable. Scratch resistant, graffiti proof. If you spray paint on it, you can clean it off without having any issues. Custom colors, custom designs, anything that you can make a digital image, we can recreate that through minerals to create whatever you want. We could create your face on a slab, you can hang that on your wall and call it art, if you'd like. Hurricane zone approved, so it's great. Impact resistance, we talked about the compaction, so that impact resistance is great. Quite a few projects in New York. This was a reclad of an existing building in New York, making that building much more efficient from an energy standpoint, saving that 30 to 40% every year, but also facelift. You can see right down to grade in New York City, could be dangerous, people, dogs, animals, dirt, grime, sleet, snow, shovels, whatever the case may be. That ultra-compact surface is going to really stand the test of time. So with 15 seconds left, I think I wrote a perfect presentation for this, but I want to end on this. It really is important for each and every one of us, not just from a manufacturer's standpoint, but each and every one of us in our daily lives to reduce what we can to make a difference. And if not each and every person in the world strives to make a difference individually, then we're never going to make a difference together. And that really leads us to a better today and hopefully a better tomorrow. So, Ben and Mercier, thank you very much.
And too keen.
Keep on going. Kingspan, and I think one of the really interesting things is part of the net zero sustainable group within Kingston, which tells you a little bit about the company, right?
Yep, 100%.
So there you go.
Sorry. Kind of gone a bit funny there. Okay. Spread out, maybe. There you go. Perfect. Well, good afternoon. I'm glad people stayed. I was a bit worried. Obviously, talking about insulation is not the sexiest of things, but it's important. So I really appreciate that. Again, what we've heard over, especially the whole day is, kind of what's changing, especially with new code requirements for the city. As Kingspan, we strive to look at kind of sustainability, performance. One thing I've seen on most presentations today is low-performing insulation products are getting used on a daily basis. Again, good products, but technology has changed and advanced. So what we want to talk about through this presentation is a new product, but a new product that's really going to help with some of these challenges that, again, hopefully people in this room are coming against on a daily basis. So let's get started. So first, I just want to start on the technology. So as I mentioned, most specifications we see in the city across the country are using kind of bulky materials that have been around for a very long time. Materials that have kind of lifespans, as everything we spoke about, but they do have lower performing properties. Again, they are getting specified for certain reasons, but again, there is new technologies out there, like our phenolic, that are going to give you higher R values. very good fire properties, better return of investment on buildings, and especially with all these retrofits, how are we going to do that without putting 6-10 inches of insulation? We do a lot of work with Passive House, Net Zero, where we are seeing 10 inches. Obviously, you can tell with my funny accent coming from Europe, before I left, we were probably doing 15 to 16 inches of CI, which is ridiculous on reclad buildings. The amount of weight that puts on, the stress it puts on. So it's all about using higher performing products to really help yourself on design. Again, it's not the sexiest thing, but it's very important when we're looking at these reclads. So what we looked at here is actually a project we are specified on. I haven't put the project name, but if you want to talk about it after, I'm more than happy to discuss it. But it's a reskin restoration project that's going to start early next year. We are specified for a couple of reasons which we're going to talk about. But one of the major, it's a large building, it's around 55 stories. They've got to bring it up to R20. It's on existing, obviously, brick structure. They're going to put a rain screen cladding system over the top. So just to show you kind of the section detail. So it's obviously your existing structure. They're going to put 2.5 inches of insulation. They're then going to put this tube attachment system, and then they're putting a stone panel over the insulation. When the architect specified the product, which is a Kingspan product, they looked into our brochure, and this happens on a daily basis, and they said, well, this thickness achieves this R value. And that is correct when you look at physical testing. And we see this on a regular basis, that it's so important to actually run analysis, because every time you put something through a piece of insulation, you're going to lose some property. A fastener, a bracket, a girt. So what we did, as soon as we kind of found out we were specified working with the architect, we arranged a meeting straight away with all the parties. So we reached out to the attachment system, the panel system, the GC, the subcontractor, and we wanted to finalize this system together, because it's so important to have everyone in one group so we can kind of collab and make sure this product's going to fit. So as I mentioned, we reached out to SFS Envelope. Because it's a reskin, reclad building, they're going to use this system, which is a newer system, which goes from slab to slab, because it gives structural support on the external side. So it's pretty much putting an external stud on your building. But the great thing about this system, again, not promoting their product, but it's one great for reclads because it's huge amounts of adjustability, but also it has thermal breaks. But you're not breaking up the insulation only at 16 inches, obviously horizontally, and then 10 or 12 feet vertically. So you're not breaking up the insulation too badly, which is very good to keep it as continuous as possible. So what we did on this kind of project when we originally got specified is sit down with the architect and say, why use a high performing product? So as I mentioned, they're looking to achieve an R20. Our product's 8 per inch. They were also looking at using mineral wool, which is around 4.3 per inch. So with our insulation, it could be 2.5 inches versus 5 inches. So it's half the thickness. What we did then was say, okay, so you're just looking at thickness to thickness. What we need to do is run some models. So as Kingspan, we have our own modeling system. We do WFI, we do 2D analysis. Because they're breaking up the insulation, 2.5 inches isn't going to achieve R20. Again, they're not breaking up on a hugely regular basis, but they are breaking up. So really, they had to go to 2 3/4 of an inch to get over to that 20 that they're requiring. So again, they had to increase the thickness. Apologize. They had to go to 2.5 inch, 2.76 because of that loss. So they actually had a 10% loss factor because of the attachment system and fasteners on this project. So then what we did is we sat down with the contractor. The contractor went to us and said, Kingspan, you're more expensive. And we get this a lot. We're selling a premium product that has more benefits. So we went, okay, let's have a look at the model of the building. And the first thing, the big issue on this project was weight. The architect wanted to have a very lightweight system. So one, thinning the insulation, you're going to take a lot of weight off the building, but also you're using a rigid board, which is bigger, it's lightweight, versus a more dense product, like a mineral wool, which comes from stone, which is around 4.5 times heavier. So we did the analysis looking at the overall building. Just on weight alone, we saved around £400,000 just by changing the insulation value, which is huge amounts of weight when you're looking at structures, especially reclad structures in the city. Then what we wanted to do was say, okay, yes, we might be more expensive, but let's see if there's a saving on kind of install cost. One of the reasons why, you're using a lightweight board, it's a lot thinner, it's 4x8 instead of a 2x4, and again, what we want to do on all of our buildings is get those contractors off probably as quick as possible and get people in. Again, that's what we're trying to do. So we ran this analysis because, again, the GC was fighting us the whole way. So when we did the analysis, we said, okay, and again, this is from the subcontractor, installing contractor, worked through this with us. So you're pretty much looking on a larger product, around 169 days versus 270 days. So again, you're taking a huge amount of time off that building just to put the insulation material, but what's that in kind of revenue? Again, this is always important, but you're saving around, over 300 grand, which is a 46% saving. Again, just by changing the thickness of the insulation and the board side of the insulation. So there is some huge benefits by using advanced technologies, especially on reclad projects. But again, we wanted to take it even further because they were still fighting us, People just don't like the idea of something more expensive. So we had to do everything, of course. So what we looked at was obviously transport savings. We've all talked about carbon emissions, taking obviously trucks off the road, which is crucial. So we looked at, with our product, we can get 15,000 square foot on a truck. With mineral wool, you're getting 8,000 square foot on a truck. So on this one project, we're delivering 9 trucks versus 16 trucks. Again, it doesn't sound like much, but again, that site, very tight site, downtown Manhattan, they don't want as many trucks. We are saving, obviously, carbon reduction as well, but you're also taking a lot of cost as well out of people's time and people's days. So again, there's another added benefit by using a high-performing product. On the kind of sustainability side, as kind of mentioned before I jumped up here, Kingspan is definitely driving this. We actually, in 2020, turned every one of our facilities to net zero. We have 179 worldwide. We actually have some pretty aggressive goals on our website called Planet Passionate. I don't have it in this presentation. But one thing we're trying to do, one is use more bio-based technology within our products. Again, as soon as you start adding into these bio-based products, you do have a knock-on effect. You do lose R value, you lose fire performance. So again, you've got to be careful about adding too much kind of bio-based because you're going to change the properties. One thing I think we get lost a lot of the time as a company, we make insulation products, and the company sometimes gets lost on the sustainability or fire properties where we should be focusing on thermal performance because that's what our products do. But again, there is other factors you have to take into account. But especially on phenolic materials, and we've all spoke today about what materials go into it. We're pretty much the lowest global warming potential product, 0 ODP. There's no fibrous materials, especially for clean air. There's no flame retardant added to the phenolic product or the cool foam product. So again, that's hugely beneficial when you're reducing smoke levels, obviously indoor air quality as well. And the biggest one for us is 89% of the energy to use cool foam is carbon zero. So it is pretty much the most sustainable product, even though it comes from a chemical-based source. Most people think mineral wool would be a lot better, but as we mentioned and we've seen in other presentations, you have to use huge amounts of heat to get mineral wool into that type of form of product. So again, with our product, you don't have to do that. But the biggest factor, again, was price, and we had to fight this throughout by using a more premium product. We were still 40,000 more. Thankfully, the architect and the GC, we went through this process and we made them a believer because of all those cost savings. But again, this is the first thing they think about is uplifting cost. And again, that's something that we need to change, and understand that premium products are going to cost more. And that's beneficial for the buildings we're working on. It's taking weight off them, it's making them more efficient, it's going up quicker. Again, these are all positive things. One thing we haven't mentioned much at this conference is about fire performance. Not to go into too much depth because running out of time, but especially now with some of the code changes in New York, I'm not sure how aware you guys are, but especially next year there's going to be a huge amounts of changes depending on what materials, combustible and non-combustible, how high they can go, fire stopping. So what's happening is NFPA has changed these regulations to make things a lot harder for certain products to be used. So now if you want to use a combustible product, you have to have an NFPA 285 test. Engineering judgments are getting reviewed, but pretty much declined on a regular basis. So something that Kingspan focuses in is testing. And these are very expensive. I'm not sure if anyone's ever seen a 285 test before. I do have a quick video, but they could be 30 to 40K per test. We've done around 15 approved tests, and we probably have another 10, I would say, in the next 12 to 24 months. But what we want to do is test every single system out there to make you as comfortable as possible using a product like ourselves. Again, we tested with all the major brands, but these big changes are going to happen. It's going to stop a lot of these highly combustible products being used. So that's why you need to look for alternate products that really give you that better fire performance. And hopefully these videos will work. And this is something to show you because, Kingspan manufactures all these products. And we're very honest about how our products perform in fire. I know it's a very quick video, but we'll see if we can go back and show it again. And this is why these products are getting banned. On the left-hand side, you have EPS. That's a thermoplastic insulation. You add a small amount of heat. This is a roof torch test. That product's completely gone. We still see these products getting used on a regular basis. On the middle video, you had your polyisocyanates that still use a large amount of flame retardants. Again, Kingspan makes these products. So we are knocking our own materials for valid reasons because they shouldn't be used. And they use flame retardants, and unfortunately what kills people in fires are typically the smoke instead of the flame. So again, some of these products shouldn't be used, where if you looked at the phenolic video on the right-hand side, our cool foam product, there's no flame retardant in it. It passes all major fire tests. And that's one thing to think about, because most people just think you have to use non-combustible products. It's incorrect. It's all about testing. If you have a tested system, that should be approved for a building. So this is 8414. Unfortunately, it must have cropped out at the bottom. This is pretty much exactly the same test as NFPA 285. And I wanted to show this to show you how extreme these tests are. And I've been to multiple of these. They're as real life as you're going to get. This system is supposed to show pretty much a non-combustible insulation versus a combustible product like our cool foam. It's a 30-minute test, temperatures over 2,500 degrees Fahrenheit with the wood crib. The test is supposed to represent, obviously, stopping the flames getting into the, let's say, apartment above with that 30 minutes to get the firefighters there. But as you can see here, both of the tests are performing exactly the same, but even though the installations are completely different. And it shows you it's about the system. We've seen non-combustible installations and non-combustible panels fail large-scale fire testing. It's all about the system, it's about the airspace, it's about having a product that has passed a 285, and if it has, then it's a suitable product. So again, we just wanted to mention this because it's important not just to get lost in combustible versus non-combustible. And you see here, this is at the end of the test. Typically how you fail is the flames will go uncontrollable, the smoke, or the fire will get to the top of the rig. Both of them are burning exactly the same pattern. And also the installations are controllable as well. If you put another type of insulation in there, you'd be failed within the first 5 to 10 minutes. So again, this is a very extreme test. Just if you wait a second, you'll see when they actually put it out. And you can kind of see the finish mark of the product. So they're putting it out now. This is after the 30 minutes, and then they do a 10-minute cool down at the end. And if the insulation recatches or the panel recatches fire, then obviously it's a failure. So as you can see there, the insulations, the burn pattern's exactly the same. Both passed the test, exactly the same system apart from the installation. So it shows you the importance of fire testing and certification. Other than that, I have 3 minutes, and I'm going to leave it there. And I really appreciate everyone's time and sticking with me. Again, I know insulation is not the sexiest thing, but it's very important. So if you do have any questions, jump by. We're more than happy to help. So thank you very much.
The next speaker's got an interesting topic here, the search of the extraordinary. So that's going to be interesting. He's the founder of the Building Innovation Arts and Architecture, and he's getting mic'd up right now, so give us a second here. And then we have our panel to conclude the day, which is going to be a great panel. I think this is why I picked this session myself, so look forward to that. Some of the leaders in sustainability. All-star, I mean, right? I mean, Nico and you know, Billy snuck in here with probably on a okay, here we go. Burak.
Hello. Hello, I hope you hear me fine. I'm just going to show you a quick video that I'm here on behalf of Turkish Glass. So to start with, there will be a quick video and then I'll start my presentation. I didn't press it. Sorry for that.
Play this video again. Play that video from there again.
Okay, well, maybe, is it not going to work? Or? Okay, so, sorry for the inconvenience, there's a problem with this video, but maybe I'll just fast forward to the presentation, if we get the presentation on screen. So. I'm just going to take you back to Istanbul. This morning we started with Joshua Ramos, was presenting Vakko building in Istanbul, which is one of my love projects in Istanbul. So maybe we can jump back to the Turkey and show you some other projects and experimentations. And again, just thanks a lot to Turkish Glass, which has made us possible to revisit New York after a long time for a pandemic. I lived in US for 10 years for education and for my professional practice, and went back to my country and started my own studio. So, and I'm going to talk about facades and some experimentation in that geography, especially, which would be maybe also reiterating the idea of the materials and the energy saving and all the stuff that we have been talking about since morning. Looking at these materials from Bauhaus education was all these basics that we learned to to design with. So these are the kind of the materials that we are handling and taking to different processes and shaping our environments. So maybe just to start with the most common one that we see on all the buildings, glass is a very interesting part of that. So in Turkish glass is representing all the manufacturers and processors of Turkey, which are globally serving many different projects and also tailored projects around the world, and has a great potential to rethink glass. And here you see that I was visiting a laboratory in this glass facility by Şecam, and this is a flat glass that they're producing. An amazing experience that seeing the factory and how flat glass is being produced. So just seeing the process of how these materials are made is really interesting for a designer to rethink how you can design. So I'm trying to adventure and see how these processes are made in each, and they're distributed from this factory, from depot. And here you see stone, masonry. Again, I was very happy Philip Hoffman talked about the energy carbon footprint is very potential in stone and wood. This is something that I'm also very interested in, to think about how we take and process materials differently. And in nature, of course, the way these stone and other materials are performed, and then when they carry out to a different environment, totally different experience. And for me, looking at a material is to also think about how you make art, and design is amazing in the way to think about forming, and form can make us into different way of experiences. Here I was in Harvard GSD collaborating with Edwin Chen, Frank Gehry's partner that time. And he has been a great inspiration for me to kind of start my own practice in Istanbul. So learned a lot from him to kind of jump into my own practice earlier when I went back to Istanbul. So I'm going to talk about some of these projects that we are doing, and also I want to group them in office, cultural, and also housing, and take you how these projects are made through thinking different materials and experimentations through design. Here you see a woven facade made of stone. This was one of our earlier experiments. In this case, we are looking at kind of behind the scenes how to cut the stone and lift it on the facade with different parts. And again, 3D model was one of the keys to, and also designing the process behind that was a big question, how we make that possible. And we literally modeled all the components and calculated and think about how to integrate to the facade. And this was a kind of like a puzzle, solving a puzzle. And the details from corner to miter joints was not easy with making with stone. So we had to create drawings to literally make these parts as Legos and put them on the facade on place. And in order to do that, there was a research done. We had to see where we can get the right stone and fabricate it, and see with different fabricators, make some mock-ups. So it was kind of like a little bit of adventure, not just sitting in the office, but also going out there and adventuring, see how it's made. And basically, it was kind of like making a model. We just started, taking all these parts and compiling, and the woven facade was there. So the idea was, to create these openings with also Iroko wood frames to make this natural stone facade into a woven, where it also created the quality of the spaces. So this is another project we designed facade for in Yalova, Turkey, which is an industrial zone making tugboats. And this is the big complex. So we are basically looking at the building at the entrance with the landscape. So we want to make some, like with brick and some glaze facade. This was a combination of looking at the potential of using these openings with the brick and the glass. So in that case, we were literally like looking at the potential of the brick as mathematical, like how to make these openings and you know, drawing each brick by brick and making a mock-up to see all these connections. So it was, you know, a play between these openings and the solid facade, where also looking at glass here, trying to see the right color that will also perform the right way in the environment of the industrial zone. Here you see one of our ongoing projects. This is about to start construction in Istanbul. Here we want to make use of stone, 3D stone and metal as a combination. This is one of the main arteries in Istanbul, coming from the Anatolian side to the European side. So this is a building for headquarters. A client want to make like a kind of a, you know, with something special with the facade. So we were looking at the potential of the, you know, the program, how the program is, you know, very simple. Like each floor is office space and all the services are at the back. So we want to kind of exhibit the facade in relation to the highway and its opening. So basically here, this is how we digested all the services and left the rentable areas for the most potential use. And basically all the windows are configured for the seating formation and creating a landscape area at the bottom. And the facade was trying to communicate with this repetitive form, so the shadows will change in time, and of course we want to make contrast of the metal and stone with this like relief, like looking at stone. So in order to do this design, we were also looking at how, you know, the cost is going to be, because these are heavy stone masonry, and also we want to make different textures with travertine. So we also want to look at the mathematics, how to make that possible, because like pretty much like a puzzle, you know, you create one window of unitized window and then you repeat it, but at the same time these stone pieces are changing as they return. So we literally modeled all the parts, and we had to test how much stone we had to cut in CNC. So this is the mapping of these stone parts around the building facade. And these are the kind of initial sketches coming to that stage. And pretty much we want to use, you know, same material and CNC surface, and also make this, you know, this is the mock-up, the testing, because we have to also see the pricing, because the client wants to go with the project, but also we have to test how much stone we need to cut, and what is the waste, and also how's that going to affect the budget. And also we want to make this texture with the same stone. So it's kind of going to be a combination. So this kind of proved us that we could really make this possible. So at this point we are in the process of building the facade. So this is one of our projects in Sakarya, Turkey. This is a headquarters building for industrial zone, representing the industrialists around the area. So basically it's kind of like building with offices and also auditorium on the left side. And the program is pretty basic, like it's kind of dual function with the auditorium and the offices on the right. So it's kind of split. So, and there's an entrance at the front with this canopy. So we want to wrap the building with these boxes with one single facade, but changing according to the program of the building. So basically with this geometrical metal sheets also trying to represent the industrial's vision, how they kind of craft and also process different materials. So the idea was to make these sheets change from the auditorium part to the offices as becoming a double skin facade, also to save energy at the south facade of the building. So this was the process of making these like origami-like panels. In that case, we were taking the sheets, and we made like nearly 20 mock-ups in 2 months to prove that these panels would become what we wanted to be in terms of quality, because basically we just bought these sheets and we had to make the product itself. So it was also pretty much developing the product itself within the project as well. So in that regard, we came to a point where we were pleased with the satinated 3mm aluminum sheet with these perforations penetrating light, and also we could also clad the canopy with the same material, and this is also we were adding light into the facade as well. So pretty much with one sheet we were able to perform different means around the facade, making the building into a state of art. And in that case, this is a perspective at night. You see through the facade inside, and then this is inside to out during day, and where you can also clean the facade. So this is the behind the scenes, how we were making. These are the interiors, and as we go inside, it's becoming transparent and at the same time changing light at different times of the day. So we want to also make a play between the inside and out by this folded skin. And at the entrance, we want to use larger panels of glass, as also we want to create this artwork on the right side, which is again 6 centimeters of stone CNC'd, and the metal created this writing, which is like we were making, and like puzzle again, pretty much. So it became like an artwork at the entrance, representing the name of the area, and the reflections created this interesting perspective. Again, this is across the same building. This is a mask for the again same zone. So we continue with the stone, natural stone, and aluminium on the minaret, and here you see use of stone and metal and wood inside, and creating a simple space for prayer, and you see this interiors becoming play with light again. So this is another experimentation with double curved. This became interestingly, we start as a kind of a design center. It was a huge building, existing shell and core building when we started. So I proposed the client to make this installation on the facade, and then after years we worked on the project, and they sold the building, and it became a university right now. So, and also it's a design center. So the program totally changed from where we started. This was some sort of a unexpected experience, but also I was happy because it became like a university space, and they flipped it into an educational space where there's also some sort of innovation center inside. So these are the interiors, and we want to make a play of this facade, create kind of like a landscape with this metal fold, double skin forms. So we literally made steel frames to hold and use cold forming for the perforated metal to create this undulated facade along the road here. Again, you see a play with light during the day. And these are 2 upcoming library projects. This is Sakarya again, and this is at night with perforated, we integrate lighting, and the open areas on the facade are showing all the common areas. And it's a program of library where there's kids session at the ground, and then there's these quiet rooms with insulated, and we hang 60 tons of steel at the entrance of the lobby, which becomes a pure bookshelf. And so it's a program of this kind of semi-open spaces and with enclosed spaces, and the facade wrapping that kind of around the circulation, which try to bring light where it's necessary. And this is kind of the details where we sold, and this construction is starting soon again in Turkey. And this is an interesting city in southeast Turkey, Mardin, historic city. This also a library program. Again, we literally like carving the mountain. So the glass is looking at the north facade, and the stone is showing the messing where other programs are. And literally when we get a section of 25 meters from the entrance, so we have these open archives, and at the bottom there is these other activities happening and a flying reading room on the top. So it's a combination of different programs coming together, but again, this interesting is like literally like carving the mountain. So the glass becomes a translucent space showing the common spaces inside. These are other further experiments, just going to go through quickly. At residential scale, again, we want to create some sort of a landscape-ish with this cubist-like facade with using travertine and aluminum. So it's kind of play of materials showing different conditions. This is another housing project on Bosphorus, which is a beautiful view. We want to use metal and glass here to optimize open views towards the water, which is a beautiful view, by the way. This is another residential with metal. Again, just going through quickly some developer project, but we again we look at these folding formations. This is in the center of Istanbul. It's an apartment building, but again we used card, CNC, and zinc. And again, this is finished right now as a combination of different materials, seeing different shapes of stones, CNC here. So it's kind of like ongoing research, and we try to adapt these know-how at different locations, and finishing with this local housing with this beautiful view with glass and stone met onto the wall with local labor from where we are. And this is our studio in the historic town, so we renovated, and pretty much this is what it was and what it became here today. So using it as our studio in the historic town of Istanbul. Thank you very much. Thank you.
Samir, I believe everyone can come up at once. I'm not going to introduce the whole panel, so I'll let Samir do that. He's the director of enclosures at SHOP. You saw the presentation this morning of the work that they do, impressive work. So the whole panel can come on up, and we'll go from there.
Hello, everyone. So I can just talk into this. Good afternoon, everyone. Thank you to the organizers here for giving us this opportunity. It's a pleasure to be here, and it's a pleasure to be here and to be talking to such an esteemed panel about a topic that we have all been hearing a lot about today, which is the question of embodied carbon in facades. And we have today with us, we have Billy Faircloth, who is a partner at and the director of research at Kieran Timberlake.
Correct.
We have Alberto Franceschet from Studio Facade Consulting.
Hello.
We have Kimberly Garcia from Tishman Speyer. You're a senior director there of design and construction. And we have Nico Kienzel who's a director partner at Atelier 10. We have such an amazing sort of a vertical cross section of the industry here. I really would like this panel to sort of step a little beyond what all we have already heard. Today since the morning, we have had some amazing presentations from various subject matter experts talking about the various points of view of the question of carbon. And I think that what we would like to do here is to try and, through the conversation, try and get a pulse of where the industry is, what we all are dealing with on our day-to-day lives, and what barriers we see in the big question at hand. So I would like to start with Kimberly. Billy. We would love for you to give us a little overview and sort of set the ground up for what we're going to talk about.
Yeah, sure. So I think one of the things we heard this morning, and can everyone hear me? Yeah, okay. So one of the things that we heard this morning, we had a number of really amazing presentations on embodied carbon. And what struck me was that the vocabulary is so confusing. I don't know if anyone else feels that way, but we are entering into new practices and new processes and really new modeling processes. And the best analogy I have for the kind of period we're entering into is that you can imagine as architects and as designers took up the process of knowing energy models and trying to wrestle with energy models, we're now doing the same thing with what is referred to as a life cycle assessment model, really trying to understand embodied carbon. And what makes it even trickier is that we now have to wrestle with time. So this morning we heard about the importance of total carbon or whole life carbon, which is embodied plus operational. But even more importantly, we know that there's urgency. And so why is there so much urgency? Well, the urgency has to do with a portion of embodied carbon, which is called upfront carbon, which is all the carbon that's being expended now, mostly on the manufacturing that's happening with materials, because we know what our timeline is for actually making change. So the vocabulary, the modeling practices are right now really complex, but having worked through tools like Tally and having been on the development team of Tally, having worked for the past 9 years on embodied carbon and on embodied environmental impacts, I can see what I've seen and what we've seen is just basically a huge transformation. But still I'm reminded of how complicated this is, but also how much we're all pulling together in a certain direction.
Thank you. I think it's a very complex issue, and it definitely is not helped by the sense of urgency that comes with it. So I would like to take this opportunity to ask Kimberly, sort of to take a step away, bird's eye view, as being in on the developer side, but closely involved with the process of design and analysis. What do you think are the big challenges in holistically sort of going headlong into starting to talk about carbon on buildings?
So there's a number of challenges, first of all. I'm coming from the developer side, the owner side, previously being on the consultant side, so understanding a combination of both. And I know you looked at me when you said sense of urgency, because it's not just about the climate, it's also the client has a sense of urgency of all these things, right? So when you start talking about embodied carbon, number one, you need buy-in. That's probably one of the largest challenges. Mm-hmm. Obviously, we've heard today, we've got sophisticated clients, you're all working with them, these are high-end buildings, but a client needs to understand what they're buying into. A lot of them will say, yes, of course we want a green building, of course we want low embodied carbon, of course we want to help the environment. And a lot of them understand what that is. But it's, I think, the charge of the experts in the consulting team that they bring on to be their confidants to explain what that really takes and what that means and through the whole life of the project, of the design of the project. Because I think a lot of times it deflates, right? You get caught up in everything else that has to be done. You get caught up in the buys. You get caught up in, money. So that's a really big challenge for us as a team, client and consultants and designers. And the second one, which I will be quick, is really about the contradictions. And a lot of what Billy was starting to explain is we talked about operational embodied energy, operational embodied carbon, and then material embodied carbon. And when the client understands operational, because that equates very real to saving money over the course of the building. But if we're talking about enclosures and facades, sometimes that means adding more material and more embodied carbon to our facades, right? So I think there's some contradictions there, and there's contradictions in the way we design and way they, want beautiful designs, and sometimes that means fenestration and detail. And how do we simplify our buildings? Because the simple buildings are going to have the least amount of embodied carbon in them as well. So that's a lot, but I think those are 3 of the biggest challenges we all face in sort of moving in this direction.
Right. So, Billy, I know that you guys, you especially, have been already involved with a bunch of initiatives within your own practice that deals with this. And so when I sort of look around and I think about my own role, as an architect working on projects, trying to, the step of learning to think in an integrated manner happened maybe 15, 20 years ago when energy modeling, et cetera, became more streamlined, and I think there was a paradigm shift in how an architect was trained and how an architect was expected to think. And now we are going through potentially another whole paradigm shift about how we train ourselves and how we think about our responsibilities and how we evaluate the quality of our own work. And especially because it starts to bring into the conversation areas about manufacturing and production and energy use that have traditionally been far away from an architect's purview. So how do you see the role of an architect and the process of design transform?
Yeah, we've absolutely seen transformation by attempting to integrate in a new modeling practice into all of the other sort of modeling practices that we have, but it's less about the modeling practice per se, and it's more about, I think, what you're talking about, Kimberly, which is really trying to figure out how do you establish a conversation around the goals for carbon, and where does that conversation start? And so what we're beginning to see, what was evidenced today, was that this is a multi-stakeholder endeavor. There are transformations happening throughout the supply chain, and those transformations are indicating that this is a kind of a multifaceted approach. So where does that leave the architect is one of the, I think, the questions that you're asking, because we can see that there are hydraulics happening throughout the industry. Clients are coming to us with embodied carbon targets and operational carbon targets, or total
higher than code.
And total carbon targets. Policy is coming at us, and we can see local, state, and potentially a national policy on embodied carbon targets. Manufacturers are completely rethinking their own manufacturing process. And so I think what we saw demonstrated today earlier in SOM's presentation, and then I think it was Philippe George's presentation, you began to see these kind of very, very specific things that architects are doing, in SOM's presentation in particular, where they're saying, okay, at the very outset, and we found this too when we found this with every user of Tally, at the very outset of the project, can you establish a goal? And when you start to jump into asking about whole carbon, can you begin to just, at an early phase, bring everyone into the conversation? The structural engineer, the civil engineer, everyone, landscape architect, everyone into the conversation, the contractor, the owner, everyone into the conversation, and really begin to understand a kind of part-to-whole relationship. So when it comes to the facade, we're talking about just simply attribution. And then from there, what we saw demonstrated earlier in the presentations was just simply the practices or the steps that we can take to actually go deeper and deeper along the entire process, go deeper and deeper into using these kinds of questions around impacts to really drive design decisions. So we can basically go through comparing options, and then we can actually begin to optimize assemblies, and then we can begin to actually do something else, which is do end-of-project benchmarking. This is a new practice. How do we begin to verify how well we are engaging the practice? Do we have to go back and we have to look at the bill of materials? Do we have to really understand how good were we at predicting embodied carbon? What's the actual embodied carbon that was expended? So these are the kinds of things that we can jump into, but I will tell you it's taking a lot of education, and in terms of educational resources, AIA in the Carbon Leadership Forum have just published a toolkit on embodied carbon for architects. Great, great resources. If you're just starting on this, I suggest you go there. It was just published last week.
That's good advice. I definitely do think that this sessions today have been quite a eye opener. So I want to move to you, Nico. I think you're the person I know who is probably the most closely involved in multitude of projects directly dealing with the question of sustainability and environmental responsibility and environmental performance. And you probably have the vastest understanding of the holistic picture of where numbers work and where numbers don't work. So I want to ask you this, regardless of everything that we've seen, from your point of view, what is the right way to think about facades within the greater picture of embodied carbon on a holistic project?
It's just an easy question. No, I mean, I think what Billy said is right. We got to have a conversation, and a holistic conversation about both sides. What do we make the buildings of, and how do we then perform over time? And I think what has been fascinating in the last couple of years is that we've seen this accelerating rate of change in how this conversation is happening and the regulatory environment that we're working in, and the supply side issues that are changing. And so things that have been relatively stable and simple, quote unquote, 20 years ago, are now fraught with a lot of uncertainty, and even questions about what is the trade-off of embodied versus operational carbon predictions. Really, you cannot make without an attitude of how fast you think the grid will be greening, right? Because if I'm renovating existing building with single glazing, then I should replace this with current energy codes and with current thinking about energy costs, obviously with double or triple pane glazing from a carbon standpoint as well. But if I assume that the grid will be green and carbon neutral by 30 years, then actually operational carbon is going to be zero in an all-electric building. It might not be cost efficient, but suddenly the question of how much embodied carbon I really want to expend today to address, reduce a loss that's really not going to be there in 5, 6, 7 years is a really important question. And so different parts of the countries, different parts of the world, different beliefs in how fast this will be changing, I think is a big driver. And then there's a larger question about, even if we assume that the grid will be changing really quickly and will be green, and we're living in this nirvana of green energy that's going to be plentiful and carbon-free, we're still going to deal with the fact that we're going to need to manage peaks and demand, and we have an infrastructure that's not there yet. Actually, Urban Green in New York is just about to come out with a mapping of the city in New York, where you say in every subgrid in the city, how much electrification, what percentage of electrification can the grid currently support with or without energy efficiency, with or without demand management. And in the most part of the city, only around 50% of electrification of the building stock will be supported by the current grid. So we're not only looking about how many PVs can we bring online, but also how can we upgrade the grids, the entire grid, which is a massive infrastructure endeavor. And all of this is only going to happen if we really then look at how much do we improve the building. So it is not an easy answer. I do think one of the challenges we're facing is that we're still living in a world where we have really good tools emerging, like Tally and others, but we're living with very incomplete information on the supply side. And so with industry EPDs on certain materials, but we have very few product-specific EPDs. And then even within a product, there's vast differences. So we've looked at very recently at carbon emissions across facades, and there are certain generalities that you can say. You can say like a manufacturer's cementitious product is performing better than a ceramic, for example, from an embodied carbon standpoint. But even within one material like aluminum, it's a massive difference of whether this is coming from a region where you have primarily hydropower powering your electrical grid, or you buying it out of a coal-fired part of the grid. And so it becomes actually really difficult then to write specifications to specify where your aluminum is coming from at this current rate. So it is really a beginning of a conversation, but it's one that I think is rapidly becoming more meaningful.
That's a great sort of springboard for a question for Alberto, because it is true that I mean, I hang out a little bit on the Carbon Leadership Forum forums, and you know, one thing that I've come to learn is that the facade industry, amongst various other building material industries, is one of the ones that is lagging the most in having created adequate or enough data to be used to properly assess, and probably partly because of the challenge of creating such data and being able to sort of become transparent about a lot of these things about their business practices. But Alberto, you have been on sort of the suppliers, fabricator side. You are now helping owners, with the complex issue of procurement, etc. What is your sense of the challenges that the industry is facing, the facade industry is facing? Or, I mean, my impression has always been that the industry stays in a reactive mode, that the sort of the leadership must come from regulations, from client side, from design side, and then the industry will sort of follow. Is that what you see as how?
Another easy question. It's gonna be tough to stay on topic on this one, because I think that he has a lot of faults. The questions. Is about the process of buyout of the curtain wall. It's going to be about the design. I think curtain wall, and Kimberly mentioned complex building and bespoke facade, because this is where you can design, where you can fine-tune the performances. And I think the industry in this sector is ready. Is currently designing for thermal, structural, bomb blast, acoustic. To me, it's going to be another requirement they will need to design to. I don't think the changes will need to happen in the process. We all agree, Nico mentioned it, there needs to be an early discussion. There needs to be, you need to have the facade consultant, educated facade consultant, but you need also to have the manufacturer at the table at the early on discussion, because these are the people that can tell you, yes, I'm going to buy aluminum from there. I'm not buy from these guys. Right. You want me to buy there? Then you take the responsibility of the process and of the manufacturing and the possible delay. So there is another level to add on to that. But I think the industry is ready. I think there is companies that are investing because they feel the sense of urgency. They feel that this is the topic of today. They see. I was the local law in '97. They know that there is going to be changes in the performances of facade, and they are getting ready also to have to be requested information on the carbon footprint of their facade, of their design, and of their supply chain, which is the missing part of the information. But I think we need also to look at opportunity in there. Right. Because I disagree that design for low carbon footprint means more expensive design. I think we need to look at the opportunity and be all together to design together the performances of that.
I actually think it's the opposite, because less,
exactly,
less
more efficient,
more.
Yeah.
I mean, not in the words of Ms. van der Hoe exactly, but I mean, the idea of simplifying the facade and the supply chain and all the parts and pieces that it goes through, I mean, it's less expensive generally than more.
Should
so
be,
that's
should
the
be.
way, I think we have to turn it around.
We have to turn it around.
So that it doesn't always, like, these conversations don't equal dollar signs for a client. They equal
Right.
actually value. And it's target savings. Think of embodied carbon as money, and you will use it sparingly.
Right.
On what you need to use and what you want to
I think that is exactly right. I think that what the big hurdle is the existing value system, the way we evaluate things, whether it is, you know, from the point of view of an owner, developer, or from, you know, what we call design performance, you know, what we are trying to seek as architects and designers. I think we have to overcome some of the value. Some of the way we value things that we value, we have to sort of change that. And I think in one of our previous conversations, Nico, you mentioned that that we're only having all of this conversation because thus far there is no carbon tax. But we also heard local law 97. There's already a penalty that is coming.
But it is I mean, I think this is one of my big pet peeves, and I'm going to lobby hard for finally stopping to externalize the cost of environmental damage. And I think if we would internalize the cost of carbon emissions into the regular cost of products, then we could still optimize for cost. There's still a lot of other externalities about potential other environmental or social impacts, but it would be a big step forward. Because we don't have that, we now need to learn all this other stuff and find these other metrics to optimize for. And I do say that local law 97, as good as it is and as revolutionary it is, New York has been on the forefront of a lot of these things, but embodied carbon is still a real blind spot in New York City. Like everything right now in the legislation is about operational and not about it.
Yeah, and the other part of this is
Easier to understand.
We have a really great vocabulary for pursuing energy efficiency, but what we're really talking about is from the outset pursuing carbon efficiency and looking at it through the whole life or total carbon lens. And so at the outset, if that becomes a goal of a project, really pursue like a high-performing facade is a carbon-efficient facade, because after all, when you look at the processes of kind of doing all of the evaluation of all the options, what you're doing is looking at a whole series of trade-offs. Or you're looking at design strategies that will naturally lead you to using less so that you can do more.
Understood.
Yeah.
Do you have to leave?
I do.
Well,
It's a very harsh reality to have one's daughter's birthday party enter into a... but I am late for her party. So I need to go. Or I'm going to miss my train back to Philadelphia, and then I will really have to make up for it. And I just...
We're sorry that we're running a little
I'm
behind
really
time.
sorry.
But you
Thank you.
I think we have a little more time to continue our wonderful discussion. But thanks, Billy, for your wonderful contribution here. You know, the question of having to modify a lot of things that we have been taking as givens for the longest time. For example, you know, the stage at which suppliers become a part of the conversation or contractors become a part of the conversation. So I mean, one can imagine, you know, what kind of issues, at least I can imagine what kind of issues architects would have if you were to say that you have to start working with a specific supply chain from early stages. But Kimberly, from your point of view, is it a reality? What changes if you start changing these basic fundamental sort of building blocks of how a project is?
I mean, actually, what you're talking about, there was a presentation earlier in this track, which was AJ mentioned design assist, and he actually gave, I don't know if anyone caught it, but he gave the true original definition of design assist, right?
Yep.
Like the contractor comes on way before, and this does happen because we consult with contractors all the time. The big curtain wall contractors that we know and love have, you know, technical teams that come and talk to architects and give us that information, and your firm now does that as well. And so we have that opportunity, but I know what we're moving to potentially is like the way it used to be. Like, bring them on early. Like, bring them on and decide that that's the horse. You have to pick your horse. And I know this is it's more popular in the contractor world, I think, than it would be in the client because of competitive nature, right? We want to keep the competitive nature as long as we possibly can. And from an architectural and engineering standpoint, you know, what if they can't do it? Or what if they cannot meet the design intent? There's a lot of what ifs. So, but it does give you all of your partnership, your team. It gives it to you early. And it's the buy-in early, and then you move forward all on the same team with the same goals. So I don't know if I'm in support of that track yet, but I think that it is something that would help this conversation, because you're deciding early with all parties, and you're talking about everything up front. You don't get lost in the competitive nature. Things get lost when you're trying to win a job. And if they've already got it, you know, there's a lot to be gained from that process. So.
Right. I have one more question, and then I'll open up the conversation for you guys to ask questions if you have. But one of the things that, you know, we are all being exposed to a number of sort of new technologies that are coming about, materials, people claiming that they're going to change the world because their material is completely, you know, whatever, low carbon, zero carbon. How, you know, this is both for Alberto as well as Nico. I mean, how do you evaluate the efficacy of a claim like that? Or how do you, you know, from the point of view of sort of risk and from the point of view of, you know, the true meaning of carbon efficiency?
I mean, I think it's not that there's no information out there. There's a fair amount of information out there now, and if you get something from a manufacturer that sounds too good to be true, or it is so vastly different from the industry standard is, then I think that's the moment when you go deeper and you ask questions, or kind of like to see why that would be and drill down deeper. But there's, I think, good benchmark information right now across most product classes out there, and I think there are tools and databases and so on. And I think we see this happening around the world, and the US is particularly difficult because it's a huge market from the supply side. You can buy materials from a very large region and internationally. We actually see it's a lot easier in Europe, where, for example, the UK, I mean, Switzerland has been doing, Scandinavian countries have done this for a while, looking at embodied carbon. The UK is looking at it much more rigorously recently as well. But it's just for a lot of the products, they don't come from that far. The supply, your realm of supply is smaller than it is here in the US. And so we can compare kind of like global differences, we can compare local differences, but the data is getting better. And I think actually with the recent changes to LEED version 4 and others, which required third-party certification of the manufacturer information, I think they become much more reliable. There are ISO standards around this now. And so.
Great. Alberto?
Yeah, and I think the process is not much different of procuring a new type of material for a building. There is obviously there is a building owner, a developer that gets very much involved. Kimberly, you're one of them. So you are there when there is the time to make the decision. You're there when there is the time to go and visit the vendor to understand more about the technical information and the data so I think it's part of it's part of a process. It's part of the design that we do when in the procurement.
The problem is you need time.
You need time.
Right. Yeah.
Because you need time to, when there is something new and innovative, you know, it does have to be tested, because unless it meets one-to-one with a building standard, you know, the architectural team, the architect is going to say, whoa, 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 it has to be tested, and you need time, and you can do it. You can get through that R&D process.
Right.
But time is, you know, the most precious thing we have.
Yes. So, any questions from anyone in the audience? I guess not. So I don't know how we're doing with time, but I do want to just open it up for you guys if you have any.
I think we're done.
We're done, right? Okay. Well, thank you again.
If I read this red blinking light down there right, then I think we're done.
Oh, perfect. I didn't notice that there was a red blinking light. But, sorry. Oh, please.
My question is, and I'm not aware if it exists now, but what structures, systems, or measures are being practiced on the developer side to hold them accountable for their responsibility to facilitate and mitigate conflict or resistance from owners who do not seek, view, or prioritize carbon reduction?
I think the question is, are there any measures or structures in place that might sort of hold owners responsible for their responsibilities?
Oh, I thought it was contractors
Oh,
responsible.
the developers.
Responsibility to facilitate and mediate when owners are in conflict or resistance of moving this way.
So you're talking about the accountability from the ownership developer side.
How are you meeting that resistance? How do you move through that conflict?
So, I think we rely on, the experts in the field, the architectural team, and if we build a team that has that expertise and when you start from programming and conceptual, start of the project, this is a little bit what I said at the beginning, you have to have buy-in for this idea. You have to, obviously a lot of clients, we're going to start, of course we're going to meet code, we're going to meet policy, we're going to do all those things for 5 years ahead. Let's look 5 years ahead. Resistance to it, if a client is going to resist it, I would say the architectural team and the specialists, the facade specialists, the engineers have to sell it. They have to make their case. And if they're really passionate about it, they need to partner up with a client that's passionate about it too, because obviously the client at the end of the day is paying for it. So they have to be, they have to be on board. And I would say, like, most sophisticated clients are going to be very much on board. You're not going to meet resistance unless you don't paint the path to get all the way to the end, because then the client's going to be like, well, you didn't get me there. So it's really back on the team to get the project to meet those goals. We're always going to throw it back on the consultant team, right? Help us get there, help us get there. So I think the resistance can be battled just by getting to a solution. I don't know if I answered your question. But.
Thank you. This was a great way to end this. Thank you everyone for your attention, and thank you all for your time.
Thank you.
Thank you. Really quickly, I'm not part of the panel, but one of the comments that was said is about time. And how do we get so innovative if we have design schedules and construction schedules and all that condensed? One of the reasons, one of the lectures I've given before, early is an example. They've developed R&D divisions within the architectural practice, and it's essentially, we have to do that kind of research outside of a project timeline to get innovative and then apply it to projects that have
6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. 1, 2, 3. Okay. 1, 2. 1, 2. Yeah, you want to talk? Here, take the mic. One, one, one. 2. 1, 2, 2. Something from there, DJ? Hold on.
The one on the far end is not getting.
Hold on. Josh, you hear me down there? Not yet. What do you mean? Not yet.
Speaking on the left turn, speaking at the podium, 1, 2, 3, 4, 5. Tapping on this one.
Okay, I hear you.
Tapping on this one. Tapping. Testing 1, 2, 3, 4, 5.
Got you.
And we also, this is a projector over here coming up, so you know, yeah, you need to be lucky.
1, 2, 3, 4, 5, 6, on the side, 7, 8, 9, 10, 11, 12, 1, 2, 3.
Stand by for PC audio.
Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 2, 3, 4, 5, 6, 7. Last. 1, 2, 3, 4. 1, 2, 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 6, hold on a second, 7, 8, 9, 10, 11, 12. Why we don't hear this? What's going on here? Check. 1, 2, 1, 2, 1,
actually a German engineering firm that has come up with a facade concept that they believe, and I think they will make a case, and a very strong one, that this will be a product for us to use in this whole local law 97 renovation or retrofitting project that we will face in the next couple of years. So, Given the delays, unfortunately, we lost Steve, but we have Stefan here still available. So, without any further ado, let me introduce to you Stefan Goebel of Friedemann here in the US.
And he asked, had anyone heard about it? And no one really raised their hand. So I started studying it, and I learned really, okay, this is something is changing in this market. Same with Local Law 15. I worked with helped the DOB come up with guidelines on how the Local Law 15 could be realized, established. So today we'll talk about a facade concept called the active cavity transitioning facade that hopefully helps cut emissions. And to me, as a passive house consulting, having emissions limits or energy use limits is really not so new of a concept. And I'll also talk a little bit about Local Law 9 and Local Law 15. Very quickly, Friedemann is headquartered in Germany, present globally, about 157 of us, solely focusing on the facade in Labelle. So facade consultancy and engineering. We've been in business since 1990. There's a couple of projects. Obviously, we've done a lot of work in Germany, and you both have developed in Germany long ago. So we're used to high energy efficient facades. We're used to high-rise buildings. We want to work in the Middle East, and we've done work in the as well. But what I think is unique about it is, so we're supporting the architectural community and developers during the design stages. But this part of the working with the general collaborative industry and always have to use it in mind. But particularly fabricators know how we are in all further step. A lot of our consultants and facade and I think that knowledge into an early design stage is going to be crucial, and then also following through during the execution of projects to make sure that the buildings that are modeled are actually performing as they've been designed is extremely important in Local Law 97. So if we want to be carbon neutral by 2050, if you want to meet Local Law 97, you all know this. We can't have this. We have to have a continuous flow throughout from design all the way to the execution. And when I heard about this the first time, I really love this. And you all can read, but as a class, being in the class industry and aluminum industry, that statement definitely shook our industry. But I do think that I was, as a passive consultant, again, I was really happy that we started having this conversation. At the same time, Local Law 15, it's extremely important to consider the system. But I do think that we don't have to ban these kind of buildings for our strategies. I want to show you one case study. radiation hits the facade, that air is heated up, it's exhausted, it can be used through a heat exchanger, or it can just be exhausted, but it's not getting into the building. So the cooling load in the summer that we have to supply can be a higher temperature. So we're shaving off those cooling, shaving off the cooling loads to push we want to bring the emission energy to the conditions. A short video here. So we looked at the operational room temperature, and so in this, for this office building here, so these are kind of the boundary conditions, we only had a couple of set points where we wrote of those conditions. So it performed really well. On the right side, we looked at the continuous daylight illumination, which we were at roughly 52% average, which is a really good value as well. If we're penetrating into the room 8 meters, so about 24 feet. One of the things that we measured as well for comfort is really important because we always have this right. So the surface temperature, as you can see on the left side, what we have here is in red is the temperature that the solar panel is simulated. Those values are pretty close to the lines and close measured and simulated. They're really but more on the right side, for comfort material, we measured the internal temperature and that did indicate more than about 7 Fahrenheit, which we really brought on. Otherwise, we have kind of get a feeling for how much heavier these kind of systems are compared to this system. We save about 25.6 inch here instead of comparing it to a double skin facade, which is significant if we think about York City's square foot values. We looked at different types of facade, and this is what I was mentioning earlier. So we looked at the U value of the active facade compared to double skin, closed cavity, box type, electrochromic, and outer shading. Outer shading always preferable, but because we gained a lot of knowledge through this, we actually processed at metals in construction design challenge in 2020. So the idea was to bring the 60s building, 63rd Madison Avenue, to a current energy standard. And so it was awarded the active facade, but unfortunately it wasn't realized. But I do believe that the original statement the mayor made, I think there's a lot of truth to it. But we do have a lot of buildings that are really, really inefficient. So there's ways to design buildings with high window-to-wall ratios that can be energy efficient. And as always, there's a team required to do this. There's Chico, Marina, there's additional research going on right now on upward, downward, screens, measuring, and also looking at different textiles. And at this point, looking at nationwide, currently, but we also looking at applying patterns to these ones. And then finally, the official next topic. So has any one of you seen a work like with windows? Birds actually approach us not at about 5 miles an hour, but 30 miles an hour. So it's deadly for them. It's estimated that about 1 billion birds die a year in North America because of bird-window collisions. And they simply can't see this reflection, or actually they're fooled by the reflection. You see the sky, the trees in this left scenario, so high reflective glass is an issue. I'm going to move on, this is awful, I know. But it also, the transparency of the glass combination is considerations. And there was a session on it earlier. So for anyone of you who has not been there, quick follow-up, New York City has introduced the strictest law on bird-friendly material requirements. So essentially any building since January 10th this year that had not been permitted, the first 75 feet have to use bird-friendly glass. 12 feet above brick and any glass corners and areas. So this is and then I want you to take that back. That's an important point. So what do we need to specify and what do we need to use to cover this down? What you will drop further and one way to get there is by the services complex. So she's worked with this for now over 20 years. Essentially, so she's created this tunnel. It's a 30-foot wide tunnel dotting inside the lake catch birds. Release them one by one in the tunnel, and once they get out of the tunnel, they're classified test classification, they're trying to understand how many birds out of 100 are avoiding this bird-friendly class. If more than 70, so let's say 70, the inverse of it is 25. That is the material threat factor. That's what you'll be hearing a lot going forward. Solutions, there's certain material, like a brick wall. Birds can see that, right? They're not going to into it. There's certain markings that we can use